This video will explain the solution to question 10 in the 2023 edition of the probability tutorial. You can access the solution to different parts of this question through the video description below. In this question, we have three events, A, B, and C, with the corresponding probabilities. We are also told that A and B are independent events, and A and C are mutually exclusive events. This means that the Venn diagram of the sample space and the three events looks like this, with A and C not intersecting and B in the middle. In part 1, we want to find an expression for the probability of A' intersects B', and hence prove that A' and B' are independent events. It is a fact that if A and B are independent, then their complements are also independent, and so the probability of A' intersects B' would be the product of the probabilities of A' and B'. However, because the question is phrased in this way, we should not be assuming from the start that A' and B' are independent. We'll have to find this probability another way. Since event C is not in the question for part 1, let us just focus on events A and B in the Venn diagram. Since the event A' intersects B' is the complement of the event A union B, the probability of A' intersects B' would be 1 minus the probability of A union B. Next, we can apply the standard formula for calculating the probability of A union B, which is probability of A plus probability of B minus probability of A intersects B. Now we can use the given fact that A and B are independent events to write probability of A intersects B as probability of A times probability of B. Finally, we substitute probability of A and probability of B with small a and small b respectively to get the expression 1 minus A minus B plus AB. Now, to prove that A' and B' are independent, we can calculate the product of the probabilities of A' and B' and show that we get the same expression as what we did earlier. The probability of A' is 1 minus the probability of A, and the probability of B' is 1 minus the probability of B. Expanding the product, we get the expression 1 minus A minus B plus AB again, and so we conclude that events A' and B' are also independent. In part 2, we're first looking for an expression for the probability of A' intersects C'. The start of this looks exactly like what we did for part 1, but now A and C are mutually exclusive, which means the probability of A intersects C is 0. Hence, the probability of A' intersects C' works out to be 1 minus A minus C. We're then asked to draw a Venn diagram to illustrate the case when A' and C' are also mutually exclusive. If A' and C' are also mutually exclusive, then the probability of A' intersects C' would also be 0. If we combine this with the earlier result, then we get the equation 1 minus A minus C equals 0. In other words, A plus C equals 1. Since A and C refer to the probabilities of events A and C respectively, this means that anything in the sample space must lie in either set A or set C. We represent this on a Venn diagram by simply drawing a straight line inside the rectangle representing the sample space, and labeling each half of the rectangle with A and C. We call A and C mutually exhaustive events. In other words, one of these two events must occur. For part 3, we are now given that A' and C' are not mutually exclusive. This means that we now have some leeway in our Venn diagram to fit in event B. We are also given values of some of the probabilities to fill in our Venn diagram later. The goal of this question is to find exactly the maximum and minimum possible values of the probability of A intersects B. Another way that this question can be asked is find the range of values of probability of A intersects B. While one might try to find the maximum and minimum probabilities by inspection, it can be quite difficult to find the right scenario to obtain the two extreme values for the probability. Here, we will use a more systematic approach that will work for questions like this. Firstly, we will let x denote the unknown probability of A intersects B, which we are trying to find. Then, we will label every space in the Venn diagram with probabilities based on the information we are given, and some of these probabilities will be in terms of x. This is A intersects B with probability x. Since A has probability 2/5, this event, which is A intersects B prime, has probability 2/5 minus x. This is B intersects C with probability 1/5. This is A prime intersect B prime intersect C prime, which is the space outside all three circles. This has probability 1/10. To fill in the remaining two spaces, we will need a little more calculation. To find this probability of A prime intersect B intersect C prime, we first need to know the probability of B. Since A and B are independent, we can say that the probability of A intersect B, which is x, is the product of probability of A, 2/5, and the probability of B. So probability of B is 5/2x, and the probability of A prime intersect B intersect C prime is 5/2x minus x minus 1/5, which works out to be 3/2x minus 1/5. Finally, to find the probability of C intersect B prime, we subtract all the other probabilities in this Venn diagram from 1 to get half minus 3/2x. Now that we have filled in the Venn diagram fully, our next step is to make use of the result that the value of any probability must be between 0 and 1 inclusive. We will apply this result to any probability in this Venn diagram that contains the unknown probability x. The first probability is that of A intersects B prime. From 2/5 minus x between 0 and 1 inclusive, we get the range of -3/5 to 2/5 for x. Don't worry about the negative values in the range. It will turn out alright in the end after we combine all the ranges. We can ignore the probability of A intersects B, as it simply gives us a range of 0 and 1 inclusive for x, which we already know. For the probability of A prime intersect B intersect C prime, 3/2x minus 1/5, solving the inequality gives the range 2/15 to 4/5 for x. Finally, for the probability of B prime intersect C, half minus 3/2x, solving the inequality gives the range -1/3 to 1/3 for x. The last step is to find the intersection of all these ranges for x, since we need to find a common range of x that would ensure every probability on this Venn diagram has a value between 0 and 1 inclusive. By drawing a number line and indicating the ranges on this number line, we can find the intersection and conclude that x must lie between 2/15 and 1/3 inclusive. Hence, the maximum and minimum values of the probability of A intersects B are 1/3 and 2/15 respectively. Here's a summary of steps to take to find the possible range of an unknown probability. 1. Denote the unknown probability by the variable x. 2. Draw a Venn diagram and fill in all spaces in the Venn diagram with probabilities, using both data from the question and standard probability formulas. 3. For any probability in terms of x, use the property that the range of any probability must lie between 0 and 1 inclusive, and solve the inequality to find a range of values for x. Finally, use a number line to find the intersection of all the ranges of x you have found in step 3.